Researchers at Savannah River National Laboratory have developed new reactive diffusive gradient samplers and microcolumns to differentiate mercury species. Sponsored by DOE's Environmental Management Office of Technology Development, these technologies incorporate targeted chemical reactions to differentiate key mercury species, while reducing analytical cost from about $1,000 to $100 per sample. Mercury contamination is the primary reason for fish consumption advisories in all 50 states. High mercury concentrations are also present inside legacy radioactive waste tanks at DOE complex sites.
It's important to industries all over the country. It's important to environmental agencies. Virtually every outfall in every stream is analyzed for mercury.
Of particular concern is methylmercury, a highly toxic organomercury compound that has the ability to bioaccumulate at higher concentrations in tissues of aquatic life than in the water, then biomagnify and become even more toxic as it moves up through the food chain.
And what we were trying to do was develop a sampler that would measure the different species of mercury, because for mercury, the species that exists in either waste or the environment is a key to how it behaves, how you can remove it, or its toxicity, how much builds up in fish. The breakthrough of our diffusive gradient samplers and our microcolumns is the innovative use of the reagents for reducing and amalgamating the forms of mercury that we want to take out and leave in the forms of mercury that we want to analyze. So the diffusive gradient sampler has several layers and each has a certain purpose. So there's a filter on the outside that just protects it. Then there's a diffusive zone that controls the rate that mercury accumulates in the sampler. Then there's a collection zone. We've added reagents either to the diffusive zone or the collection zone to basically push mercury around and bend it to our will.
The DGSs were deployed into waterways at Oak Ridge National Laboratory and the Savannah River site. After a specified time, the samples were collected and taken back to SRNL for analysis.
We're looking at the same chemistry in microcolumns because we want to give ourselves the maximum chance of having success and having diverse solutions that come out of the laboratory. So once we got the samples back to the laboratory, the microcolumns would go onto a shaker table. Then we would simply filter out the sorbent that we had put in there.
No matter the species being sampled for, both technologies can utilize a standard total mercury analyzer as the final step. The simple and inexpensive technology has real-world commercial and research applications in environmental monitoring, aquaculture, and equipment manufacturers and suppliers.
So we actually have 2 patents that have been applied for, one for microcolumns and one for diffusive gradient samplers. We've had several companies contact us with some interest in licensing the technology and hopefully widespread use of the technology, not just in DOE, but by others outside DOE.